Hey Huskies, welcome to section 2.4, video 2 on transformation of functions. We're going to go ahead and get started with example 2, and we're going to continue working with this superintendent problem and this heating problem throughout the rest of this section. So in this example, the superintendent is changing everything in the heating to start 2 hours earlier. So this blue graph is representing everything, and they want us to come up with a formula. They want us to check a temperature when T equals at 2 p.m., and then they want us to shift this graph. Well, the graph is shifting at 2 p.m., so if you read through most of that, which I don't want to do right now, everything backs up at 2 hours. So the building begins now to warm at 2 a.m. instead of 4 a.m. So everything's moving left 2 hours. So when I look at this graph, when I'm going to graph this, what I want to do is try to look at some key features. And I want to look at these points because these dots here represent a point, a temperature, and an hour. And those are the ones I can kind of shift over because I can see those really well. They're getting shifted, everything's getting shifted over 2 hours. So I'm going to make tick marks in between on the x coordinate because those are the 2 hour marks. Those are halfway between. So like it said, 4 a.m., it's not 4 a.m. anymore, it's 2 a.m. Now technically I'd have to shift 0.50 over 2 to -2, but that's really not going to work because you can't have a negative hour. But you could consider maybe that 10 a.m., right? I know 0 is considered, I think they said 12 a.m., so 10 p.m. the night before, okay? At 8 is going to go to 6, so right about there. 16 goes to 14 right about there, here, and here. So I've moved all those points just 2 units. I had to lean over there 2 units to the left, and so I'm going to connect my new points as best I can, and so we'll see this nice little shift over of 2 units. So everything moves, everything starts earlier, the whole path. Okay, so there's the graph, there's part A. Part B, they want to know at 2 p.m. Well, if you're thinking Army time, 12 is 12, and if you go 2 hours past that, that's 14, right? You know, you start at 0800, that's 8 a.m., right? So 2 p.m. is T equals 14. So on part B, when T equals 14, we got to look at our graph. So let's use our graph. Here's 14 here. I'm going to just draw a line up, and you can see that we're at 70 degrees Fahrenheit. So when T equals 14, whoops, our temperature H is going to equal 70 degrees Fahrenheit. Okay. And in part C, they want an equation. So you can come up with maybe, I don't know, let's say new temperature is going to equal, now we mess with the inside, we mess with the X value, so we're actually going to shift this. It's going to be T plus 2. We didn't shift the X value, we shifted the T value, the temperature. Okay, so it's plus 2. And you're thinking, well, Mr. Bennett, I moved left 2 units. Why is it plus 2? And remember, the general formula for a shift is this, X minus H plus K. Doesn't matter. What happened in ours is that we moved 2 left. So that means our H value was negative. And when you subtract a negative, right, 2 hours left, that becomes positive. So remember that. That's a trick. Okay? So let's just write this summary. The general rule, be really careful on the horizontal shift. You have to think opposite, and let's just start there first. If g of x is a function and h is a positive constant, then the graph g of x plus h, which I just mentioned, is going to be shifted h units. I'm going to say h units left, or it's going to be, excuse me, I'm sorry, I should just say left by h units. And if you have g of x minus h, the sign doesn't change inside there, you're going to move right h units. So horizontal shifts, that's the tricky one. Should say right there. There we go. We're a little delayed there. I apologize. And then vertically, what you see is what you get. Okay, so if you have something here, g of x plus k, you're shifting vertically upward, vertically up by k units. if you have g of x minus k. So notice how as plus k you go up, minus k you're gonna still shift vertically, but you're gonna go down by k units. Okay, so that's the summary there. That's really important. That works for all of these functions. Okay, square root, quadratic, cubic, doesn't matter. Inside versus outside. Here, if we mess with the inside, we have an inside change. Right? If we mess with the inside of our function. If it's similar vertical shift to something like on the outside, it's an outside change. Okay, because we're changing the output values, the y values, okay? So that's it for this particular video. I'm going to come back and complete the rest of this section with examples 3 and example 4. So if you have any questions, please let me know. We'll see you next time.